Okay, so the image that we're going to follow today is going to be an image that I started via an on-demand job, and it also is going to go through dedupe and then through remote dedupe. So we've asked for a job. pserv sees the call from the scheduler or the UI, because in this case I did in fact click on demand, and it starts to kick off the mechanisms that I described in that 9-square slide, where we're talking to the UDS agent, we're talking to OMD, we're talking to UDP. We've got all 5 of these services now all working in concert to manage our physical disk, to talk to our host, to start to present that physical disk to the host, open network paths, and then start ingesting that data. So if you want to see how this works, the best thing to search for at this point in the job is really going to be the job number. So as you can see here, by searching for the job number, now you will notice one weird thing about the logs. I did cut the timestamps out, and that was for no reason other than screen real estate. So you will have a full timestamp preceding each one of these log lines. So as we can see here in this example, we've searched for the job line. And as I go through this presentation, I'm going to mention some words for you that you could search in these particular logs to bring you to the important part. When we get to that slide, those words will be bolded. So you'll see what kind of search results you would have gotten had you used some of these keywords that I suggest. So here we can see everything is going well. We've found our iSCSI initiator, we've opened the path, and we're able to then talk back to OMD. And at this point, we're about 9% into the job. And we can say, OMD, we found the agent, we're able to talk to it, we've opened a good data path, please give me a disk so I can attach it to this host and start writing. Now, if for some reason this path was offline, either physical media was unplugged, your multipath settings had it set into a perpetual queued mode, or perhaps your iSCSI network is QoS'd, and the QoS has shut down the path to allow better throughput on other links. Searching for the job number is still going to bring you to the critical piece of information here. Now you'll notice we go from an info log level to a warn log level, and it will say right in the logs, we know what path you've asked us to use, but we either cannot find it, which is generally going to be a physical media disconnect, or somebody has reconfigured the iSCSI in the host, or that path is either offline or into a perpetual queued mode. Now, I've mentioned this perpetual queued mode 2 times. In some multipathing software, you can specify the behavior that a path should take when it runs into an issue. So the 2 that I really want to focus on is queue if no path. If you have a setting for queue if no path, what will happen is if you do have that QoSing, or there is a media disconnect, the IO from the host will just sit waiting to go in there, and nobody was going to send an alert. And the reason nobody's going to send an alert is because everybody is adhering to the configuration they've been given. It was told to queue if there was no path. So it didn't fail to the next path, and it didn't issue an alert. It's queued just like you've asked it to. The suggested setting here in a true multipath setup, where you really do have multiple paths to your disk set, is fail if no path. If we can't connect, we will fail that path, and then we'll try to access the next available path to that host or storage. And we will go through that cycle 5 times before we, at that point, say, we just can't make a good connection. We're going to cancel the job and report it to you as failed. Okay, so we're going to go back to the beginning part of my example, where we do make a good connection. So that was from the UDP log, and the UDS agent has a corresponding log entry. So pserv said to UDP, I want a snapshot. UDP said, okay, let me talk to the UDS agent. UDS agent, are you there? Is your host available? And you can see here I have in highlighted letters, hello connector. That is the log line to look for to ensure that the CDS or Sky instance has made good contact with your host. If you do not see hello connector, it means we couldn't get a signal from the source appliance into the host. And I've also highlighted at the bottom here, it gives you the version of the connector it's talking to. So if you're running version 719, and unless you have a very specific special use case, your connector should also be at 719. And this initial handshake actually does have some other really nice information in it. We can see a little bit further down that this is a log smart backup, that we do have AES 256 capable encryption that we could flip on by just putting a tick in a box. So when you find your hello connector, look a couple lines above, a couple lines below. There's some great context there again, which would be great for tool building or any sort of automation effort that you're trying to get into. Now we'll focus a little bit more back on the Udppm.log. Now some search terms here for the initial part of the job is going to be the job number. We're going to look for the term UDS agent, and we're also going to look for ESX. So you can see here, this is from UDS agent. We just saw the hello connector. As you can see here, I have highlighted received UDS agent response. That means we said hello connector, the connector said, hello, I'm here. And then we can see some additional logging around here. There's not a lot of context here, but you can kind of dig into a little bit to kind of understand what's going on. We show the compressed size of the app. This means that we've seen it before. If the compressed size is a one-to-one match with the actual size, it means we've never seen this data before and we're not really sure how small we can make it. So as you can see here, we've got our comp desired size and then our comp size. So we know that we've seen this before. We've seen it at the 510, et cetera figure, and we know that we can squish this down to the 425, et cetera figure. So now that we can verify that the Actifio appliance is connected to the host, we can also check to make sure that we're using the right iSCSI path. And we can also verify this without the UDS agent. Instead of talking to the UDS agent, what we would do for a non-connector enabled host is we would reach out directly to the ESX or vSphere node, cluster, or host that it lives on. Now in that case, again, we're going to search for the job number you can see here. And this is the important part. Message, expected one, got one entries from host agent data with ESX host name, and then we have an IP. Now, if we expected one and got 0, that means we tried to reach out to an ESX host that we had talked to before. We were able to log some details around it and run a good discovery on it, but for some reason we can't talk to it now. So if you are having connectivity issues, looking at this expected one got X, and if you're in a clustered environment, it could be expected 10 got 9. And then it will enumerate everything that it was able to talk to, and by process of elimination, you would say, okay, well, it sees these 9. The only one that's left is clearly the one that we can't talk to. So now that we've made our connection, either via the UDS agent or by talking over the ESX or vSphere API, we've confirmed good host connectivity. Now we want to make a staging disk. So here we're going to search for the job number, and we're also going to take a look for the word hint. And this again goes back to just making sure that we are in the incremental forever model. If we are, as you can see here, the second to last line, it says backup hint object, and then it's got that hex value after it. That is a hex value that has been assigned to the previous image. That lets us know, hey, we have a copy of this image on board. We don't need to ingest the entire app from ESX. We'll just grab the change blocks. Now, for the exact same operation, I did the same thing, but I had actually removed all of the images and I forced a full, and then we get this log message here. Backup hint object, not found, performance warning, full ingest. Now, if you're onboarding a new app, you fully expect this. We need to see it once before we can start deduplicating. However, if you have a job and you feel like maybe it's running a little bit long, it's just taking much more time than you feel like it should. You can go into the UDP log and you can search for the word performance. If you find that performance warning next to the corresponding job number that has you curious, then yes, you have encountered a full backup, and that would explain why your backup is running long. However, if you see the backup hint object, then it is a true incremental. You may have just had a large amount of change data, and it's just taking a little extra long. However, this can also point out things like faulty points in infrastructure, improperly assigned QoS, or even a physical interface that's not behaving well. Okay, so now we are actually going to call the staging disk. Now, I said before I took out all these timestamps. We've been talking for a few minutes now. In machine time, if this was happening live on a CDS or Sky, maybe 2 or 3 seconds have elapsed. This all happens very, very quickly. It does take me a bit longer to explain it because while I'm explaining to you one thing at a time, the CDS or Sky appliance is doing 5 things at a time. So at this point, we've connected to everything. We've verified everybody's good. We talked to either our agent or our ESX host. We are ready to attach a disk and start capturing that data. So again, the UDP engine for the staging disk is going to talk to OMD, Object Manager Daemon Service, and it's going to locate an existing staging disk. If this is an incremental, it'll bring that existing staging disk forward. We'll use that as an index. We'll only capture the change blocks. If we're unable to find a staging disk, then we will create a new one. This will be a full ingest, and you will see that performance warning notation in your log at the beginning of the job, generally within 2 or 3 lines of the job number. Now, in this case, we grabbed Vdisk. This is a VUID in this example, and we can actually map this VUID. Now, for other scenarios, this could be a UUID, and all these unique identifiers can be mapped in your UI, and you can actually follow the trail right to the physical disk that it lives on. So if you're unable to find a disk, you may have a path down to your storage. You may have had a disk that has stopped responding. The RAID set could be rebuilding. You could then trace down where that Vdisk lives to go look at the physical health of that storage array that actually hosts the M disk that the Vdisk is carved from. Now, if that did happen, if we did have a RAID set rebuild, the pesky janitor used their mop handle and pulled the cable out of the storage, we would see a message similar to below. This is failed to fetch Vdisk details for. Now here's the ID of the staging disk. So in this instance, I had an image. I had already backed it up once. I had already deduped it. I made sure the machine was well aware of it. And then I actually took the storage that hosted the Vdisk out of zone to force the error. So if there's a connectivity issue to the storage, if we are queuing if no path instead of failing if no path and we can't get to the storage, or really any sort of network transmission interrupt out to the storage, or a physical hardware breakage, this is what you're going to get. You will get a failed to fetch Vdisk details for. Now at this point, we can either try to repair that storage, bring that Vdisk back to then be attached to the host, or we can go into the connector settings and we can just tell it manually to run a full. So back to the more successful version here. So as we go through, I do have one image that goes through the whole chain, and then I do break it out into separate jobs to force some errors just to show you what the logging on that looks like. So once we've identified and verified that we have the incremental staging disk again, then UDP says, OMD, mount it to the host. OMD, again, Object Manager Daemon, then takes that Vdisk or staging disk and mounts it to the host. Now, if this is a Windows machine, once this disk is mounted, you'll be able to go into VDS, your virtual disk service, or your disk management UI, and you'll be able to see this volume mounted there. Now for Linux, FS tab. If you go into FS tab, you will see the staging disk has been mounted to your host and we're ready to write to it. And we can see here this middle log snippet that we have in blue. This is just what you could look for to verify that things are going as you expected. You know, we found the disk, we're not seeing any errors. We're gonna search for the job number. We're gonna search for the VUID or the UUID, depending on where our storage is coming from. And we can also search for OMD. Generally at this portion of the job, which is gonna be around 6 to 12%, if there is a failure, it's because we've either failed to connect to the host or OMD cannot get to the staging disk. So if you're having a job that's failing right in that certain percentage range, again, about 8 to 12, do some searches for OMD in these logs once you've got them on your desktop. And if it is an issue with OMD finding that old staging disk, it'll pop right up for you. Now, the OMD log itself doesn't have a ton of good information in it. It generally is just logging its responses to queries made by the UDPPM. I'll be referring to it as UDP, Universal Data Pipeline. So the UDPPM or UDP queries. So this bit of logging on the bottom is actually the response in OMD for the request UDPPM in the snippet above. So as we can see, it's not really that useful. It doesn't give us a lot of context, but the fact that we can see a response lets us know that the service is online, the socket is open, and it's listening. If we didn't see a response and we were failing to find the staging disk, then we could make a pretty well-informed guess that something is going on. Maybe the OMD service is offline or something is preventing the UDP service from being able to make that request or stopping the request from being honored. Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.